Okay, so let's look at what we're doing with gradients and slopes a little bit different. What if instead of trying to figure out what the slope is at a certain point, or the gradient is at a certain point, what if instead we try to figure out at what x value is the gradient a certain slope? Is the gradient a certain value? So here we have an equation. It's the graph of x squared plus 4x minus 4. This is what it looks like. Now, as both sides of the graph continue out, it starts to get steeper and steeper and steeper and steeper. But at what x value does the gradient reach 100? So it's going up 100 per y value, okay? Well, let's think about what we need to do that. We need to know what is the equation for the gradient. To do that, we have to find the derivative. So we're going to take f prime of x, okay, which is 2x plus 4. So that's the equation that's going to tell me the slope or the gradient at any x value, okay? So I want to know, well, where does it equal 100? Well, all I have to do is I just have to do 2x plus 4 equals 100. Now think to yourself, do you divide by 2 or subtract 4 first? If you said subtract 4 first, you're correct. Minus 4 gives us 2x equals 96. Divide by 2, divide by 2. X equals, what would that be? 45, 48. So once we're all the way out to 48, way over here, okay, the gradient, or the slope of the line, is going up at a rate of 100. All right, let's look at another problem. Now we're trying to figure out where does this graph, and actually it's going to look different. I'm sorry. It's going to look something more like this, okay? Where is it going, where's the gradient, the slope, going to be 10? Well, 10 is going to be positive, so it's going to be somewhere here on this left side. I'm just not exactly sure where, okay? Well, if I want to figure out where, I need to take the derivative. F prime of x equals negative 2x plus 4, okay? Well, where does it equal 10? Negative 2x plus 4 equals 10. Minus 4 gives me negative 2x equals 6. Divide by negative 2, divide by negative 2. X is negative 3. So when x is at negative 3, that is where it will have a slope of 10. Okay? Here we go, we've got another problem today. Let's look at this one. So we have an x cubed graph. We want to know what points on the graph have a gradient of 10. Looks like there might be two. There's probably one somewhere over here, and there's another one somewhere over here. What are the x values? I don't know. That's what we're going to do. So I need to first take the derivative. That's going to give me x, let's see, bring that down, x squared minus 2x. When I bring it down, 3 times 1/3 is just 1. Hence, it cancels out. Minus 70, okay, that's f prime of x. That is the equation to find the slope at any given point. Well, where does it equal 10? So that gives me x squared minus 2x minus 70 equals 10. Ooh, this is starting to look like a quadratic. Remember, we are going to get 2 answers. So I'm going to subtract 10 from both sides. That gives me x squared minus 2x minus 80 equals 10. Ooh, sorry, equals 0. What was your teacher saying? All right. What two numbers add to be negative 2 but multiply to be negative 80? They are x plus 8 and x minus 10. So what are my x values? What x values make this true? Negative 8 and positive 10. So right here at negative 8, when x is negative 8, our slope, our gradient is positive 10. Over here, when the x value is at positive 10, our slope is also positive 10. All right, let's try another problem. Let's figure out when are these two equations parallel. Right, over here we have a graph. It's going to look something kind of like this. Over here we have a graph that's negative, so it's coming down. At what point are they parallel though? Okay, so if we're drawing them on the same graph, we'd have graph 1 and graph 2. At what point are they parallel? You know, I should probably, instead of calling this f of x, this is going to be g of x, because they're not the same equation. All right, well, to do that, we need to figure out the slope, the gradient of each equation. So here, the gradient is 8x plus 3, because I took the derivative. If I take the derivative over here, g prime of x, which you shouldn't really even need to do, but we're going to do it anyway, we get negative 5, okay? That's the gradient, it's the slope. So, if I want to figure out where are they the same, where are they parallel, where they're parallel, that means the same, not touching necessarily, okay? There could be a half-mile distance between those two numbers for all we know. Let's see here. We've got a sum equal to each other. 8x plus 3 equals negative 5. Minus 3 from both sides. 8x equals negative 8. Divide by 8. Divide by 8. X is negative 1. So at negative 1 is when they have the same slope. We don't know how far apart they are. But let's do that right now. Let's figure out how far apart are these two when they are perfectly parallel. Okay. Well, I take negative 1, I just plug it into here, I'll get a y value. 5 minus 2 is going to give me, g of negative 1. 5 minus 2 is 3. Over here, if I plug in negative 1, let's see here. That's 4 minus 3 minus 5. That's negative 4. How far apart are they at negative 1? They are 7 apart. Okay. All right, let's try this problem real quick. When are these two lines parallel? They look scary. Give it a quick try, pause it, see if you can get it. Remember, just take the derivative of both sides, set the derivatives equal to each other, go through, figure out what the x values are. I will give you a hint. They are parallel twice. All right, you should have paused the video. You should have your answer by now. Let's figure out what it is. So I go through and I take the derivative of both sides. I've got g of x. Hey, come on in. G prime of x. All right, we've got g prime of x equals 3x squared minus 3x plus 25. We have over here f prime of x is 4x squared minus 5x plus 10. We good so far? Perfect. Now we need to figure out where are they parallel. In order to do that, I need to set them equal to each other. So I've got 4x squared minus 5x plus 10 equals 3x squared minus 3x plus 25. We good so far? Perfect. So I need to get this all over to the same side. So I'm going to subtract 3x squared from both sides. That gives me x squared. I'm going to add 3x to both sides. That's going to give me minus 2x. I'm going to subtract 25 from both sides. That's going to give me negative 15 equals 0. That was a lot of work. Well, I'm not done yet because I don't know what my x values are. I've got a quadratic equation set up. I can go through and kind of figure this out. I need to think what two numbers add to be negative 2 but multiply to be negative 15. Negative 5 and positive 3 are the two numbers. Now, those aren't my answers, okay? My answers are what x values make it 0, positive 5, and negative 3, okay? So if we're looking at these two graphs, one of them is going to be somewhat narrower. Now this one's going to be narrow, this one's going to be wider. So you've got one that comes down and then back up. You have another one that comes down and back up. Where are they parallel? Roughly there and there. Just like that.